we're going to kind of not even look at. Rates of change in polar functions. So a common thread throughout every single unit has been rate of change. That's how we'll end the lesson today. But first, I want to make sure that you understand the relationship between a graph like this, which is 1 plus 2 sine theta, and it's graphed for you in the polar plane. Remember, you don't have to know the name of that graph, okay? You should have the skills, and you're going to get to practice this over and over and over again today. You should have the skills. If I tell you the equation of a sine or cosine function, you should then be able to sketch it out in the rectangular plane. Now, they were nice and they did that for you. So here's that same graph, 1 plus 2 sine x, in the rectangular plane, xy. I think I'm going to teach this to you a little bit easier than I did first period. If I tell you that this axis right here acts like the origin, and the vertical axis is your radius, think r. The idea of what you're going to learn on the first page and practice on the second page is, what interval is this graph getting further away from the origin, and what intervals is this graph getting closer to the origin? Now, based on all I've told you so far, can anybody tell me one of the intervals on this graph where the graph is getting further away from the origin? Like from where to where? And so I want you to be using these as you're telling me that. 0 to pi over 2. Okay, and I'm going to color code this. If you can quickly find 4 different colors, great. If not, it's not that big of a deal. From 0 to pi over 2, this graph is moving farther and farther from the origin. Okay, cool. Getting farther from origin. Now, that's 0 to pi over 2. So I just want to make this connection for you really quickly. If you are looking at this graph on a polar plane, I'm going to use that same color to color code this. This is the part of the graph that starts on the like the polar axis. Think of it like the x-axis, and it goes all the way up to the tippy top there to point B. That's that point of the graph. It's moving farther and farther and farther away from the middle. Kind of think of it as spiraling out. I start closer to the origin and I'm moving out farther from the origin. And then I kind of like peak right here. Notice that's the maximum of this graph. That's not a coincidence. And then on this interval from pi over 2 all the way to where is it going to move closer to the origin? Pi over 2 to where? 7/6 pi. 7/6 pi, I'm at the origin again. So getting closer to origin. In other words, listen to how I say this. The distance between the points and the origin are decreasing. The distance is decreasing because it's getting closer and closer and closer to the middle. Well, on the polar graph, so I'm going to use that same color. On that polar graph, here is where that piece of the graph shows up over here. From the top, spiraling back all the way to the middle, to the origin. And then this part of the graph is like that little loop, because here's what's going on with the little loop. There's a small piece of the graph that's now moving farther away from the origin, and then it hits that minimum value from 7/6 pi to 3 pi over 2. Farther away, that's this little piece right here that's starting at the origin and moving to the top of the little loop. My last color is going to be red. I'm now moving closer to the origin, but I stop at 11 pi over 6. I'm back at the origin. I was far away. Now I'm moving towards the origin, so that's this other half of the loop. Now, I'm going to go back to my original color. So whatever color you used here, if you're a person who's color coding, this might be helpful, okay? I'm back to where I'm at the origin and I'm moving away from it. On this little bitty piece right here, if you've been really careful, you can see that that's just this little scoopy part right here. That's that last piece, that last component, like the bottom of the butt cheek or something. Okay? That's how this is all related. You can see maximums and minimums, but really I'm going to tell you this. If you can take what I've highlighted and you can sketch out the graph on a rectangular plane, you're going to be A-okay. That's really kind of the theme of this polar stuff. So let's fill in this table because you guys did a great job of explaining where things are moving closer and farther away. What intervals, there's 2 of them, is this graph positive and increasing? What does positive mean? Above the axis. Negative is below the axis. So we're looking for positive and increasing. Where is that happening? 0 to pi over 2. So you're going to have to write kind of small in this top box because you're going to write 2 different intervals. From 0 to pi over 2, and just as a reminder, we don't use or equal to when we're talking about increasing and decreasing because you can't really say that the graph is increasing at 0. That doesn't make sense. Where else is this positive and increasing? 11/6 pi to 2 pi. Squeeze it in there. The rest of the boxes you'll only have to write 1, so you can write a little bit bigger. And I'm just kind of color coding this as I go as well. Where is the graph positive but decreasing? Pi over 2 to 7/6 pi. Now he kind of went out of order here, and that's fine because it kind of makes you think. What about negative and increasing? There you go. Yep, 3 pi over 2 to 11/6 pi. Negative and decreasing? Now this first page of notes is very redundant. That's why I'm kind of skipping and just showing you the pertinent parts. There's no doubt in my mind you guys are good on this. Now the bottom, all it's saying is this. You were able to tell me really easily, we're getting further away, we're getting closer. We're getting further away, closer, farther away. Okay? This down here at the bottom is saying the same exact thing. You do not have to memorize all of these bold, underlined words. If you can see it in a rectangular plane, you're going to know, look at how this is worded though. The distance between the function and the origin. The distance between the function and the origin, increasing means you're getting farther away. From origin. Your distance between you and something else is increasing. You're getting farther and farther and farther from it. And then here we're getting closer to the origin. The distance is decreasing between the function and the origin. And then we're getting farther, closer, farther. And you can kind of see that how that happens in that rectangular plane. So all of that says the same thing. Turn page. We're going to start with example 3 because they have the graph for you. So it's a gentle one to start with. We're mainly needing to spend time seeing how the questions are asked so that when you are sitting during the test, the AP test day, you're not freaked out by the question. So look at all of this. It's really, really wordy. It says, here's a graph, 3 sine of 2x It's graphed on this interval from 0 to 3 pi over 2. I can tell that in the picture. If this polar function r equals f of theta, where f of theta is 3 sine 2 theta, look guys, that says the same thing as what we just highlighted here. Same exact thing. It's just saying on a polar plane, if we graphed the same one, which of the following intervals is the distance between the point and the origin decreasing? So here's the real question. On what interval is the distance between the point and the origin decreasing? If your distance between you and something else is decreasing, are you getting closer to or farther from that object? You're getting closer to it. I want you to take your whatever writing utensil you have. There are 3 parts of this graph that start far away from the origin and move towards the origin. Mark those 3 places on this graph that start from far away and move closer to. Here's one. Here's one. Here's one. And only one of those is an answer choice. Don't say it out loud. Give everyone a chance to kind of glance through there. Only one of those intervals is an answer choice. Bless you. What did you choose? C. 3 pi over 4 to pi is one of those that we marked. That's not a really difficult concept, I don't think. It's one of the easier ones we've tackled. Now, what if that had said increasing? If that little word right there was different, increasing, then I would be looking for either 0 to pi over 4, that would be answer choice A, or pi over 2 to 3 pi over 4, that's answer choice B, or pi to 5/4 pi, which is D. So just be sure you're reading really closely. Now we're going to go to example 2, and the reason that this one is a little more difficult, again, is because they don't give you a picture of that. You have to draw that. If you don't have that skill, you cannot do any of these problems. So here's how you take that and figure out what it looks like in a rectangular plane. We're going to come right down here to this blank space, and I want you to write that as -4 cosine theta plus 2. And the reason I'm having you write that is because back when we talked about transformation, this is how you saw these, when we practiced graphing these before. So you should know things like where the midline is, what the amplitude is, what the period is. Oops, I spelled that wrong. What's the midline? 2. It's whatever is being added or subtracted. What's the amplitude? It is 4. Now last period, a couple of them said -4. It's 4, so what job does the negative symbol have? Very good. So this cosine graph, which again is going to either start above or below the midline, well now I know it starts below the midline because of that negative symbol. So we'll take that into consideration as we're sketching it. Now, how do you figure out the period again? You're going to need this a lot on Thursday's test. Some 2 pi over b, and some people have that, but then they're like, well, I don't know what b is. What is right in front of theta? 1, essentially, 1 theta. So period is 2 pi over 1, so the period is 2 pi. We're going to take all of that, and we're going to be able to graph this on a rectangular plane. So I'm just going to coach you through how I do this in case it's helpful. If I know the midline is up there at 2, then I'm just going to drop this axis down a little bit so that I can draw a midline right here at 2. And then I look at the fact that my amplitude is 4. Pay really close attention to this. Somebody came up to my desk last week And they had a misconception. When they were graphing an amplitude of 4, they went up to 4. But you need to go 4 above the midline and 4 below the midline. And that tells me how tall I'm going to draw this thing. Now let's look at how we use the period. The period is 2 pi. So I'm going to complete one whole cycle between here and 2 pi. And then I'm just going to give myself some guiding marks. If that's 2 pi, then halfway is pi. And half of that is pi over 2. That would make this 1/4, 2/4, 3/4 pi. We may or may not need to go back and add more stuff, but for now, this will help me sketch it out. So if I've got a cosine graph, if it wasn't reflected, I would start up here. But because it's reflected, I'm going to start down here. I'm going to give myself some guiding points. Now, if I kind of think about it, I've got to complete one whole cycle. So that means that I'm going to reach the midline at pi over 2. I'm going to reach a maximum at pi. I'm going to come back to the midline at 3 pi over 4. And I'm going to reach the minimum again at 2 pi. So now I can carefully draw that curved graph. You have to be able to take a function and graph it in the rectangular plane. You just have to, if you want to get these right, okay? Now let's go through the answer choices and kind of look at something. I'm noticing, I'm going to let the answer choices guide me, that they have like pi and 2 pi in them, which is great because I've got that marked already, pi and 2 pi. What I don't have marked anywhere is this 5 pi over 3 that shows up on every single answer choice. So they're kind of telling me 5 pi over 3 is important here. I need to figure out where 5/3 pi is. So like figure out, and you've got to be good with like fraction knowledge, is 5/3 pi, like it's going to be between where and where? It's going to be between 3/4 and 2. And guess what? There's no coincidence. If you were careful in your sketching, it's right there where you should have crossed that axis. So I'm going to have to use an arrow because I'm out of room. But that right there is 5 pi over 3. Now we can go through each answer choice, and what we're going to do is we're going to pick these apart. We're going to mark through the single word that makes this wrong. Look at A. The distance is increasing. In other words, it's moving closer to or further from the origin. Further away from the origin from pi to 5 pi over 3. Now look, pi to 5 pi over 3. Is that getting further away from the origin? No. So that word made that answer choice wrong. And if you kept reading, there's another part of it that makes it wrong. It says that from pi to 5/3 pi, we're positive and increasing. No, we're not. We're positive and decreasing. So if you want to move ahead of me, look at B. The distance is increasing, so we're getting farther away from 5/3 pi to 2 pi. Now, I do agree with that. But it says because the graph is negative, I agree with that, and increasing. No, it's not. It's decreasing. Okay. C. The distance is decreasing. So we're getting closer to the origin from pi to 5/3 pi. Yes. Because we're positive, yes. And decreasing, yes. You have to pick it all apart. If you don't read the end, you might have accidentally picked B, because B was right all the way till the very end. And then just glance at D and make sure you know why that one's wrong. The distance is decreasing from 5 pi over 3 to 2 pi. No, it's increasing. The distance between the graph and the origin is increasing there. All right, let's move on. He kind of wants you to memorize something. Again, I don't think it's necessary that you memorize this at all. This is talking about when you see like relative extrema, that means like maximums and minimums. Maximums and minimums. And all he's going to tell you here is if your graph changes from increasing to decreasing, or if your graph changes from decreasing to increasing, that means you have a maximum or minimum. Now you're going to see why in a second. That's kind of a, well, yeah, no, duh, because you're going to see it right in front of you. Here's what we're going to do on example 4. We're going to consider this graph 1 minus 2 sine of 2 theta. We're going to graph that in a rectangular plane, and then we're going to really be able to just move through our answer choices and see very easily which one it is. Now, I kind of skip over looking at this sometimes, and I'll tell you, sometimes this gets me into trouble. If I find that the period is pi, sometimes I'll just go out to pi, which in this case is fine because it says to graph it on 0 to pi. But I'll show you on page 4 of the notes why you have to read really closely. All right, let's do this like we did the last one. Down here, I want you to write negative 2 sine of 2 theta plus 1. You take a second and make sure you're understanding the midline, the amplitude, the period, and the fact that it's reflected. And it is a sine graph, so we're going to start on the midline. And then double check that you got all of those right and start graphing this thing out. Sine, S, it has been reflected. So we're going to dip down. We're going to come back up. We're going to reach a maximum and back down. Do you have any questions on anything that's up there that you didn't quite understand? Okay. Now again, let your answer choices guide you. Every single answer choice has like pi over 3 or 2 pi over 3. So clearly those are kind of important. Now where in the world would pi over 3 be? 1/3. In between 1/4 and 1/2. So here's where we're going to just estimate pi over 3b. What about 2/3? Yep, somewhere in here. And you really don't have to be super accurate, and you're going to see why. Let's go through these answer choices. A, the graph has a maximum from pi over 3 to 2 pi over 3. Pi over 3 to 2 pi over 3, which is about right here. Does the graph have a maximum between here and here? No. Oh, excuse me, the minimum is what it says. Does it have a minimum between here and here? No. B, the graph has a minimum from 2 pi over 3 to pi. 2 pi over 3 to pi. Is there a minimum there? Nope. C, the graph has a maximum from pi over 3 to 2 pi over 3. Maximum? No. D, the graph has a maximum from 2 pi over 3 to pi. Yes. Now, here's the thing. At the top of your page, what you highlighted or underlined or what I was pointing out is the fact that, watch, we change from increasing to decreasing. And that's how I know that there's a maximum. But I don't have to cram that in my brain because I can see right there's a maximum. Once you graph it, you're good. Okay, last little thing I need to teach you in AP Pre-Calculus is the rate of change of polar functions. Here's the great news. We've seen this a million times before. Rate of change, the slope. That's rise over run. That's y2 minus y1 over x2 minus x1. I talked about that in 8th grade, and 9th grade, and 10th grade, for sure. Same thing. It works with polar functions. It's just saying if you're asked to find the rate of change on an interval from A to B, plug in B and see what you get. Minus. Plug in A and see what you get. All over B minus A. Watch how easy that is on example 5. The hardest part about example 5 is not getting to use a calculator, okay? Consider the graph of this polar function right here. That's what we're going to be plugging into. What's the average rate of change on the interval from pi over 2 to pi? Those are the things we'll be plugging in. This is like your A and your B. So we're going to plug in pi. And here's how we're going to do this. Over here, because we're going to work horizontally across the page. 3 minus 3 cosine of pi minus, and I'm going to use brackets because I have to subtract all of what I'm about to write, minus 3 minus 3 cosine of pi over 2. All divided by b minus a, pi minus pi over 2. And let's just move horizontally. Let's kind of pick this apart. What this blob of stuff says right here is 3 minus 3 times whatever cosine of pi is. 3 minus 3 times, think of a unit circle, but do not look at one. Go to pi. What is cosine of pi? -1. Very good. Now we'll come back to that. Minus 3 minus 3 times whatever cosine of pi over 2 is. So I want you to imagine a unit circle. Go to pi over 2. What is cosine of pi over 2? Very good. 0. Let's go ahead and clean up the bottom here. We've got 1 pi minus half a pi. What's 1 minus a half? A half. So another half pi. Half pi over 2. Here is the part that some of you are going to get frustrated by. Does anybody want to take a shot what all of this simplifies to be? 3 minus 3 times -1. It's not 0. It's 6. What? How does that turn into 6? PEMDAS says you have to do what first? You have to multiply first. What's -3 times -1? 3. What's 3 plus 3? 6. This next part's a lot easier because 3 times 0 is 0, whatever. You're going to get 3 right there. But you have to multiply and then do your addition and subtraction. Okay, we're to the easier part. Keep going. And if you ran out of room, just move to the next line. That's 3 over pi over 2. And we're just going to clean that up and we'll be done and we'll move on. This is how you find the average rate of change. It's really easy. I mean, considering. That's like 3 times the reciprocal 2 over pi. We've learned that skill enough to know that's like 3 multiplied by 2 over pi, which is 6 over pi. That's it. Go to the back. The very last page of notes ever. You have this polar graph. Yes, it's a rose with 4 petals. You don't have to know any of that. Here is the function that's graphed right there. It's 3 sine of 2 theta. On which of the following intervals is the average rate of change equal to 0? Okay, wait a minute. Average rate of change equal to 0. Well, when we were younger, we learned that rate of change is slope. What kind of line has a slope of 0? All lines are straight. That's okay. That's the most common answer. Horizontal. There you go. You redeemed yourself. Okay, so horizontal. Keep that in mind. We're just looking for a horizontal line. Now, you have to be able to graph this. You have to be able to take 3 sine of 2 theta, pick it apart, and draw it out. Midline, 0, amplitude, 3, period, pi, 2 pi over 2 is pi. Excellent. And then, has it been reflected? Do we start on or above the midline? On. Pause for just a second before you start drawing. Sometimes I get ahead of myself, and so when I'm drawing it out, I'll just go all the way to pi. But look really closely. It does say go all the way out to 2 pi. So you're going to draw 2 complete cycles. 2 complete cycles. If you don't do that, you're not going to get the answer. So the midline is 0. Nice. Have to go to 2 pi. Amplitude is 3. Okay, now be careful when you're drawing this. It's different than the rest of them because, again, the period is pi, which means I'm going to make one complete S shape by the time I get to pi. And then I have another complete S shape by the time I get to 2 pi. The big picture here is I'm looking where I would have a slope of 0. Let's go through the answer choices and see. From pi over 4 to 3 pi over 4. Okay, here's where pi over 4 is. Here's 3 pi over 4. So watch how I show myself, okay? The graph is up here at pi over 4, and it's down here at 3 pi over 4. If I connect those dots, will I have a line with a slope of 0? Oh, no way. It's got a very negative slope. So A is out. B. At 3/4 pi, the graph is down here, and at 5/4 pi, the graph is up here. If I connect those dots, I'm not going to have a horizontal line. I'm going to have a positive rate of change. So that's not it. From 3/4 pi to 7/4 pi, here's 7/4 pi way down here. 3/4 pi to 7/4 pi, if I connect those dots, do I have a rate of change of 0? Yes. And there's no reason to sit through answer choice D, okay? The hardest one in the whole entire thing is example 7. And the reason it's difficult is Let's read through this. It says, in the polar coordinate system, the graph of a polar function is shown. Does it tell me what that function is anywhere? So how in the world am I supposed to graph this out in a rectangular plane if I can't do what we've been doing where we find all the stuff and graph it? Yes, you could figure it out without doing what I'm going to show you, but I think this is the easiest way. This is really how my brain has to do it. If you have taken just a little bit of time and you've watched the flipped math videos, if you haven't, you probably want to watch them, so I'm going to show you. He does a really good job of explaining how to take a polar graph and write the equation for it, and it's not hard. This is a cardioid. It's open down. Cardioids mean that your first and second number will match. I know this is a sine graph because it's open down. I know that it's a negative sine graph because it's open down. The sine opens up and down, cosine opens left and right. He'll also show you in the video that this number plus this number, whatever's in the blanks, will add up to be the farthest point from the origin. In other words, this graph comes all the way out to 6. If you're watching how things are labeled, this graph comes out to 6. Now, if you know that those have to match and they have to add to 6, what do they have to be? 3 and 3. Now, you can do it like all the other problems. What's your midline? 3. Has it been reflected? Yes. What's the amplitude? What's the period? 2 pi. And the midline is 3. So we're way up here. The amplitude is 3. Pi. It's a sine graph that's been reflected. Now, we're kind of stuck. If you've gotten this far, that's great. But it says, on which of the following intervals is the average rate of change the least? The least means the most negative slope. Most negative slope. So in disguise, you're trying to find from point what to what do you have the steepest negative slope. Now, we're still kind of stuck. Where's all this A, B, C, and D coming from? Well, if you read, it says, on this interval, the graph passes through labeled points A, B, C, and D in that order. So look at point A, where the radius is 3, and you're at 0, that means point A is right here. There's point A. Where do you think point B is located on this rectangular plane? Point B is sitting over here at pi. So it's going to be right here. Yeah. What's the rate of change on average between A to B? 0. So answer choice A. The slope from A to B is 0. Now, if that ends up being the smallest one out of all the answer choices, I'm going to pick it. So I don't know if that's it yet or not. Now we got to figure out where C is. So C is where we're moving farther and farther from the origin, but we're not quite at the maximum. So watch. C is not quite to the maximum, so I'm just going to mark C somewhere there. And then I reach the maximum out here, and then I'm coming back closer to the origin. Do you notice that there's some symmetry here between C and D? That's going to show up over here as well. What's the slope from C to D? It's also 0. You have enough information to answer this. From B to C, are we positive slope or negative slope? Positive. From D to, now, what happens there? D to A, there you go, there's A. From D to A. That is the smallest, the least, the most negative slope out of all the answer choices. D to A is negative. We did it. You did it. I'm very, very proud of you. Now, because we don't mess around in this class, I want you to get your extra practice that the sub gave you on Friday, the 310 and the 312 extra practice. If you need another copy, come right over here. I'm going to tell you what questions are very important to look at. No, let's stop the first two things. There's 310. All right, look at the 310. Okay, I'm trying to give you some really good information. You guys, the free response is going to terrify you on Thursday. I feel like you know right now. Okay? You've got an easy free response, and you've got a challenging one. Can you do one? Is one of those that you've seen a million times where it's like a real Ferris wheel or something, and you have to graph it, and you guys can do a great one. And get all the points. And then we turn a paper over here and have it. So, on 310, number 4. On your 310, it says on worksheet C, 310 part 1. Number 4 is critical. That's not to say the rest of them are unimportant, but know that one for sure, okay? Then, on the 312 extra practice, it says worksheet B. Really, all of these are important, but hone in on 4, 5, and 7, and here's why. 4, 5, and 7. When you're adding and subtracting any fractions, it doesn't matter what the fractions are, whether you have cosine or sine, whatever. When you're adding and subtracting fractions, you have to find a common denominator. On 4, 5, and 7, you're forced into figuring out how to do that and using that skill, which you will need on the free response on the test. Now, the last thing I'm going to do with you before I leave you alone is I'm going to give you a problem. We're going to work together. I'm probably going to write this down. Want to write this down somewhere. Trying to find it. No. Okay, write that down. You're not going to get to use a unit circle on the test. You're not going to have a unit circle race or anything like that. So you're going to have to learn how to quickly draw that out for yourself if you want to do it. Okay? You can do it however you want. Now, let's say you're working on when you get to this. How would you solve for x? So that's what we're going to learn right now. Because technically we didn't see anything like this in the notes. So I don't want to leave you hanging. How to read this is cosine of what is negative 1? Cosine of what is negative 1? You've got to know your unit circle. Cosine of how many radians? What did you say? Pi. That has to be pi. Because cosine of pi is negative 1. Here's the catch. The directions say find all the solutions on the domain. There's no restricted domain. They're not just going from 0 to pi. You can keep going around the circle, and around the circle, and around the circle, and around the circle. So what does your answer need to have in it? Can you remember those? It's got the K thing. Be more specific. You're getting there. It's not plus 2K. What is one complete rotation around the circle? There you go. So again, if the directions say find all the solutions on the domain and then they don't give you any sort of restriction, that just basically means until infinity. So when I go to pi, yes, cosine is negative 1, but I can rotate around the circle and hit it again. I can rotate around the circle and hit it again and again and again and again. Okay. Now, if I know that what's in the parentheses has to be pi plus 2 pi k, how do I set this up to solve for x? If I now know that what's in the parentheses has to be or equal pi plus 2 pi k. You almost got it. We're going to say that 2x has to equal pi plus 2 pi k. Do you understand why we did that? Because I know what's in the parentheses has to be pi plus 2 pi k. So I'm going to set them equal to each other. And we're almost there. The very last step to solving for x would be what? Divide by 2. Okay, divide what by 2? Everything. And I like to split it up so I can simplify as I go. So my final answer that I would put on this free response question would be pi over 2 plus pi over k. We didn't really ever see those steps embedded in the notes or the homework. But if you'll look at example number 4 on that 310 that I told you about that was so important, you're going to run into this situation. So there's another time you get to practice it before you see it on the test. Okay, you're on your own. Prioritize. Figure out what it is you need to do to prepare yourself for the test on Thursday. You can sleep in tomorrow, or you